Hello friends, welcome to this session. Today we are discussing about the classification of electronic communication and need of modulation. So let us see the classification of electronic communication. Electronic communications is classified into the three groups, that is the unidirectional and bidirectional communication, means the direction of communication. Second type of the communication system is the nature of communication signal, and the third one is the technique of transmission. In this way, the electronic communication is classified into the three groups, and the direction of communication is again three types of, that is the simplex system, half duplex system, fully duplex system. And the nature of communications are of the two types, that is the analog, that is nature of communication signals. There are the two types of the signals, that is the analog and digital type signal. And the third, that is the technique of transmissions, are again the two types, that is the first one is the baseband transmission and the second one is the communication using modulation. So this is the classification of electronic communication system. So let us see the first type of the classification, that is the based on the direction of communication. Here there are the different types of the direction of the communications, and that is classified in the three types. So first one is the simplex system, and the simplex system is nothing but the information is communicated in one direction only, and when the information is communicated in only one direction, that type of the system is known as the simplex system. And here the information flow is in only one direction, and the example of that is the radio and the television broadcasting. And in television and radio broadcasting, the informations or the signals can be sent from the radio stations or the television broadcasting station to the receivers only, and the information cannot be transmitted or received from the receiver to the transmitter. So this is the first type of the system, that is known as the simplex system. Now the second type of the system is half duplex system, and the half duplex system is the bidirectional communication. Okay, and in this bidirectional communication, the signal can be transmitted or receiver at a time, only at one time, means it can be transmitted or it can be received, but simultaneously both the transmission and the reception is not possible in this system, that is known as the half duplex system. And the example of a half duplex system is walkie-talkie. Okay, so in the walkie-talkie, this signal is transmitted and received, but at one time only. So next type of the communication is the fully duplex system, and in the fully duplex system, this is the real bidirectional communication system. In this case, the signal can be transmitted or the received at the same time, means simultaneously reception and the transmission can be takes place. And the example of this is the telephone. In the telephone, we can send the signal or we can receive the signal at the same time. So this is the classification of the communication according to the direction of the communication. Okay, so next type of the communication classification is based on the nature of information signals. And in the communication, electronic communication, we are using the two types of the signals, and therefore according to these two types of the signals, the communication is classified. So this is the analog and the digital signals. There are the two types of the signal. First one is the analog signal and the second one is the digital signal. And the analog signals are like this. This is looks like the sine wave, and that is actually the physical quantity is represented with the help of such types of the signals, that is known as the analog signals. And here the signal is vary with time, that is known as the analog signal. And the second type of the signal is the digital signal, and the digital signals is like this, that is the on off or 0 1 type of the signals. This signal is also vary with time. So let us see these two types of the signal. Analog signals changes continuously with time, and the example of that signal is the temperature, pressure, or we can say the sound, picture are example of the analog signals. Okay, and the digital signals changes suddenly from the 0 to 1. Yeah, signal is either 0 or 1. Okay, and here there is the sudden change, that is not continuous change in the digital signals. And the nature of this is the digital type of the signal, and the example of the digital signal is the computer data. Similarly, the analog signal is exact representation of the physical quantity. The physical quantity is exactly represented with the help of such types of the signal, that is the continuous signals. But the digital signal is the approximate signal. Okay, and it is always an approximation of the physical quantity. So this is the difference between the digital and analog signal, and the error introduced in representing a physical quantity is very small. When we represent the analog signal, that is we can represent the physical quantity, and therefore the error which is present in the analog signal is very small. But in the digital signal, that digital signals are approximate signals, therefore the large error can be found in the digital signals. And the bandwidth requirement for the analog type of the signal is very less, but the bandwidth required for the transmission of the digital signal is large. Okay, so these are the two types of the signals, that is the analog signal and the digital signals. And according to these signals, we can classify the electronic communications. Okay, so this is the classification based on the nature of signal information. Okay, now next one is the classification based on the technique of the signal transmission. So let us see how the electronic communication classify according to the signal transmissions. Here the signal transmission can be two types. In the electronic communication, the two types of the signals, or in the two ways the signals can be transmitted. The first one is known as the baseband signal, or that. So let us see what is the baseband signal. as you've seen that the analog or the digital signal, okay, and that analog or digital signals are converted into its electrical equivalent signals, and the electrical equivalent of the analog or the digital signal is known as the baseband signal. For example, suppose there is the sound, and the sound, suppose the sound is in the analog type of the signal, and that sound is the physical quantity, or the pressure is the physical quantity, and that sound signal is converted into the electrical signal. When we convert the sound signal into its electrical signal, then that electrical equivalent of the sound signal is known as the baseband signal, and the baseband signal can be transmitted as it is when we are converted into the electrical form, and when the baseband signal is transmitted directly, then that type of the transmission is known as the baseband transmission. And example of that is the telephone network. In the telephone network, we only convert the sound signal into its electrical equivalent signal, and that is transmitted only, that is put on the electrical wire, that is the cable, and then it can be transmitted from one place to the another place, and that example is the telephone. Okay, so this is the baseband signal and baseband transmission. Okay, now let us see the second type of the communication, that is known as the communication using modulation. And this is the new technique in which the signal can be transmitted from one place to the another place. So this process, that is known as the modulation. In the modulation process, baseband signal is called as the modulating signal, and another high frequency signal which is known as the carrier signal. In the modulation process, we are using the two types of the signals, that is the modulating signal and the carrier signal. Okay, so modulating signal is the baseband signals, and these two signals are mixed in the modulation process. And here the function of carrier is to carry the information, or is to carry the modulating signal. This is the modulating signal. Okay, baseband signal is the modulating signal. Okay, here this is the motorcycle. Okay, and this is the man which is sit on the motorcycle. Similarly, this is the another vehicle, that is known as the car, and here we can use the car or motorcycle for the journey. When we want to go from one place to the another place, then we are using such types of the vehicles. Okay, we can use any type of the vehicle. For the long distance, we are using the vehicle, and for the very short distance, we can walk. Okay, but for the long distance, we can use such types of the vehicles, and these vehicles, like as the car and motorcycle, carries the human. Okay, so here the carrier is the car or the motorcycle, and the information is nothing but the man or human which is sit in the car, or which is sit on the motorcycle. So this is the information. Okay, person is the information signal. Here the person is the information signal, and this vehicle is the carrier. So these two types of the carrier can be carry the information or the person from one place to the another place, and the same process is used in the communication system, that is known as the modulation process. So this is the actually modulation. In modulation, we are changing the baseband signal into the high frequency signal. Okay, we will discuss detail about the modulation process in the next session. So this is the classification of the electronic communication, 3 types of the classification. Okay, now let us see why we need the modulation. What is the necessity of modulation? Or we can we send the signal from one place to the another place, that is the baseband signal? No, we can't send the baseband signal from one place to the another place, or the sound signal or picture signal as it is from one place to the another place. We need the modulation. So let us see the advantages of the modulation, and there are the different types of the advantages. The first one is reduction in height of the antenna. Second one is avoid mixing of signal. Third type of the advantage is increase the range of communication. Next one is multiplexing is possible when we are using the modulation process, and this is last one, that is the improve the quality of reception. In this way, these are the different advantages when we are using the modulation process. Okay, so let us see the advantages, such types of the advantages one by one. First of all, let us see reduction in height of the antenna. How the antenna size or the height of antenna is reduced when we are using the modulation process. Okay, for sending the signal from one place to the another place, we require the transmitting antenna or the receiving antenna. With the help of transmitting antenna, we can send the signal from one place to the another place, and the size of antenna required is height of antenna is equal to lambda by 4. And here what is the lambda? Lambda is nothing but the wavelength. Okay, and here the lambda or wavelength is equal to c by f, and here c is nothing but the velocity of light, and f is the frequency of the signal. Okay, so the velocity of light is 3 into 10 raised to 8 meter per second. Here there is some errors. This is not 10 raised to 3, but this is a 10 raised to 8. We know that the velocity of light is 3 into 10 raised to 8 meter per second, and the frequency f is the frequency of the signal which is to be transmitted. Now consider the frequency of signal is 10 kilohertz. Okay, we know that the sound signal having the frequency from 10 hertz to the 20 kilohertz. Suppose we want to send the signal and that the frequency of the signal is equal to the 10 kilohertz. Then let us find out the how much size of antenna is required, and therefore the lambda is equal to 3 into 10 raised to 8 divided by 10 into 10 raised to 3. Okay, by using this formula we have to calculate the wavelength, and if the wavelength is divided by the 4, we get the size of antenna. Therefore, for that purpose, let us find out the wavelength lambda. Okay, lambda is equal to this much, and here this calculation is 30,000 meter. Okay, and when we find the height of antenna, minimum height of antenna is equal to lambda by 4. 30,000 divided by 4 is equal to 7.5 kilometer, and such types of the antenna is required for the transmission of the signal which having the frequency 10 kilohertz. And this antenna size is very big. Practically we can't construct the antenna which having the size or the height is equal to 7.5 kilometer. Okay, so this is not practically possible to construct the such types of the antenna. Okay, now let us consider the another type of the frequency instead of using the 10 kilohertz, let us take the frequency that is the 1 megahertz frequency. Then the lambda is equal to 3 into 10 raised to 8 divided by 1 into 10 raised to 6. 1 megahertz means 1 into 10 raised to 6. And here C, this is the C. C is equal to 3 into 10 raised to 8. This formula. Okay. And 1 megahertz is the frequency of that is equal to 1 into 10 raised to 6. And this calculation gives 300 meters. Okay. And if we divide the 300 by 4, then we get the size of antenna, and the height of antenna is 75 meter. And it is possible to construct the such types of the antenna which having the 75 meters. So here let us see the size of antenna is changed from 7.5 kilometer to the 75 meter. If we increase this frequency again, instead of 1 megahertz, if we are taking the 10 megahertz, then required size is equal to 7.5 meter. In this way, we can reduce the size of antenna. Okay. In the mobile, you see that in the mobile, the size of antenna is very, very small, and there the frequency is very, very high, which is in the megahertz. Okay. So with the help of the modulation, the size of antenna can be reduced. Second type of the advantage is mixing is avoided, or avoid the mixing of the signals. Okay. If we are taking the two signals from the two stations, suppose this is the first signal, okay, and this is the second signal. These two signals transmitted from the separate radio stations. Okay, and we know that the frequency of the audio signal is 20 hertz to the 20 kilohertz. Therefore, these two signals are having the same frequency, that is from suppose 0 hertz to the 20 kilohertz, 0 hertz to the 20 kilohertz. When these such types of the signal is transmitted in the space, then they can mix with each other, and we can't separate such types of the signals. Once they are mixed with each other, means when the two sounds are mixed with each other, then we can't separate that type of the sound. Okay, but instead of using such types of the direct transmission, suppose the transmission is using the modulation. And in the modulation process, what we are doing, we are keeping the audio signal or video signal on the carrier wave. So this is here the carrier wave is 100 kilohertz, and this signal is placed on such types of the carrier wave which having the frequency 100 kilohertz. When we mix these two signals with the help of modulation, or here the modulated with the help of the carrier of 100 kilohertz, then we have the frequency that is from 80 kilohertz to the 120 kilohertz. Now this is the second signal, and suppose the second signal is modulated with the help of 200 kilohertz. Here the 200 kilohertz is the carrier. Using in the example of the modulation, we are using the motorcycle or the car or the aeroplane for traveling the large distance, or for when we want to go from one place to another place, we are using such types of the vehicles, and that is known as the carrier. Here also this frequency is the carrier, and the function of this frequency is to carry this audio signal. Okay, and here we get the second channel which having the frequency from 180 kilohertz to the 220 kilohertz. Now this is the third signal. Okay, and the third signal is modulated with the help of 300 kilohertz, and therefore we have the channel which having the, or we having the frequency 280 kilohertz to the 20 kilohertz. If you are looking towards the frequency, here the frequency is given on the x-axis. Okay, here the frequency is varying from 80 kilohertz to the 320 kilohertz, and there are the separate frequency. Here this frequency is different, this frequency is different, this frequency is different, and therefore if the frequencies are different, then there is no chance of mixing, and here in the modulation process the mixing is avoided. Okay, this is the second type of the advantage of the modulation. Now let us see the next type of the advantage, that is increase the range of communication. And range means what? Distance. How much distance the signal can be travel from one place to the another place. When we are sending the signal from one place to the another place, it covers or it travels some distance, that is known as the range. And here the range is increases with the help of communication. Suppose this is the baseband signal, and baseband signal is very low frequency signals. Okay, and if we send the baseband signal as it is from one place to the another place, it can travel very low distance, because the baseband signal having the low frequency, therefore its energy is very low, and due to the low energy, when the signal is sent from one place to the another place, the more attenuation can be takes place. Attenuation means loss of the signals, and here the signal is lost and the losses is very high, and therefore it can reach for the low distance, so the range is very low. Suppose the second type of the signal, that is the modulated signal, and the modulated signal having the high frequency signal. If the frequency is very high, then the attenuation is low. Here the attenuation is inversely proportional to the frequency. If the frequency is high, attenuation is low, means the loss is low, and due to the high energy it can travel the more distance, and here the range is very high in this case. So this is the second type of the advantage with the help of modulation, that is the increase the range of communication. Now another type of the advantage is multiplexing is possible. Multiplexing means what? Multiplexing means the many into the one, means through the one cable or through the one wire the number of signals can be transmitted, and it is possible only with the help of modulation. We can send the different types of the frequencies, like as 100 kilohertz, 200 kilohertz, 300 kilohertz, 400 kilohertz. In this way, number of frequency can be sent from one place to the another place, and that can be separated on the other end of that cable, and this is only possible due to the modulation process. Means the multiplexing is possible, means the number of signals can be sent with the help of same cable, that is known as the multiplexing. Now next one is the quality reception, and here the quality of reception can be enhanced with the help of modulation. In the modulation we can use the frequency modulation or the digital modulation, and in these cases, that is the frequency modulation and digital modulation, unwanted signal cannot be entered to the such types of the modulation. Okay, and therefore the quality of reception is very good in the frequency modulation or the digital modulation. So these are the different advantages of the modulations process. Okay, so in this way, if we are sending the signal with the help of modulation, then that is very convenient to send the signal from one place to the another place. So these are the advantages of the modulation. Okay, so in this video you've seen that the classification of modulation and the need of the modulation. Okay, so thank you for watching this video. Okay, good day.